Hello and welcome. Eitan Suez here, Technical Marketing Manager at Solo.io. In this lesson, we're going to discuss integrating kgateway with Istio at Ingress. And this subject requires an explanation, and so I'll enlist an illustration to help me explain more or less what the issue might be or what we're trying to do in this particular lesson. So here we have an illustration of some workloads running in a Kubernetes cluster, and there's an assumption here that we're running a service mesh. We're going to be running Istio in ambient mode, and that affords encryption of the communication, of the connections between the workloads internally inside the cluster. It also affords workload identity, which is the foundation for enabling authorization policies when we configure the communication between the workloads. Furthermore, we see that we're using a kgateway as an ingress gateway in this particular situation, handling requests from clients, and the assumption is that by default we typically favor HTTPS listeners that terminate TLS at the gateway. And so that leaves the question of, well, how exactly is the connection between the gateway and a target workload, whether it's something that exposes an API endpoint or an application? What is the protocol for that? By default, unless we don't do anything, unless we do something, that upstream connection is going to be sort of a plain text connection. And so this is the concern here, is how exactly do we do this with Istio? Ensure that we have end-to-end encryption in all the connections that we see in this diagram. Now, there is a write-up on the Ambient Mesh website titled Integrating Third-Party Gateways and Ingress Controllers. And the example that you'll see on this website uses the venerable Nginx Ingress controller as the example. So what I basically want to do is demonstrate how this is done with kgateway, how we can use, instead of an Istio native gateway, we'll use the kgateway project to provision our gateway and still configure mutual TLS for that upstream connection between the gateway and the backend workload. So that's what are we going to do? I'm going to demonstrate how this is done. We're going to step into a lab in just a minute, and we'll essentially set up the stage as you see here. It's a slightly simpler example than what we just looked at. We'll have a single workload. We'll use HTTP bin. We'll deploy that. We'll install Istio, and we'll configure HTTP bin to be part of the mesh by labeling its namespace using the data plane mode convention label. And then we'll provision a gateway and configure a routing rule and route request to HTTP bin. And we'll, in the process, also learn how do we tell whether that connection is using mutual TLS or not. And there is another page on the Ambient Mesh website that discusses different ways in which we can verify that mutual TLS is enabled. We can look at the zTunnel proxy configurations. We can look at metrics that contain a security policy parameter that tells you whether mutual TLS is employed. We can confirm it through the logs, which is the primary mechanism we'll use in this lab that's coming up. Specifically, we're looking for source and destination identities, as shown here, having spiffy IDs. And the other way to do this is through Kiali by looking and inspecting through an observability tool such as Kiali the actual properties of the connections between workloads, between the gateway and the target workloads. So there's different ways to do this. So this is what we're going to do. Let's go ahead and step into our environment. We'll launch our instruct lab here, and we'll proceed through the steps. So we already have a kgateway deployed, and very little else. So we'll start by deploying HTTP bin to its own namespace. We'll use the HTTP bin namespace to deploy that, and we can look at the pods in the HTTP bin namespace. So that's up and running already. And then we'll install Istio, and we'll do it the simple way with the Istio CLI. We'll run istio cutl install. And what I've specified here is the profile being the ambient profile. So we'll have zTunnels and everything that the ambient profile sort of enables. And I mentioned that we're going to look at the zTunnel logs to ascertain whether we have mutual TLS communication happening. And so in order to do that, I'm going to basically set up sort of a 2-panel layout and run kubectl logs on the zTunnel workloads so we can inspect them. And then in the bottom panel, we'll actually run a variety of commands. And we'll begin by labeling the HTTP bin namespace with data plane mode equals ambient. This is how in Istio with ambient mesh we actually make that workload a part of the mesh. And so we'll run that. And it's interesting to sort of observe what happens in the zTunnel log, the fact that zTunnel has been made aware of this workload so that it's able to sort of configure the mutual TLS communication that will happen between this workload and other workloads in the mesh. So then we'll turn our attention to provisioning a gateway with kgateway. Notice the gateway class name is kgateway. So this is a just a simple port 80 listener. I try to keep things simple, and so we'll go ahead and apply that. And as we know from previous lessons, that will actually provision us a gateway, and we can look at the sort of default namespace we have our gateway running, and that's great. And then the next thing to do, of course, is to configure our gateway to route requests to the HTTP bin workload, have a way of sending a request through the gateway to our target workload. And here you notice the host name httpbin.example.com is used as a mechanism to sort of select that backend ref or a matcher, let's say. So let's go ahead and apply that route. And now we have a route, and we should be able to verify by sending a request through the gateway, so we can capture the gateway IP address. We've done this in a very similar way in previous lessons. And we can send a request to httpbin.example.com to the headers endpoint and see that we get a response. So we indeed do get a response. And the thing to pay attention to at this point is that if we look at the logs in the top panel, we see this info message, access connection complete, and a variety of parameters, the source address and destination address, and the conspicuously missing pieces of information are the source and destination workload identities. And that is what this write-up tells us, is that if we want to confirm mutual TLS is enabled through the zTunnel logs, we should look for a source identity and destination identity, and we do not see those parameters in the logs. And so we don't have mutual TLS in that upstream connection from the gateway to the HTTP bin workload. You can see the source, there's destination service is the HTTP bin, and the source workload is my gateway. So we definitely are looking at that particular connection. So the first thing we can do is we can run an istio command, ztunnel config workload, and notice that although for HTTP bin, the protocol is HBone, the HTTP-based overlay network environment, the tunneling mechanism that Ambient Mesh relies on to perform mutual TLS. The gateway in the default namespace uses just a plain old TCP protocol. So that's another way to tell that we're not doing mutual TLS yet. So how do we enable it? And this is really the beauty of this particular integration is it's nothing special. All we do is make the gateway a part of the mesh as well by simply labeling its namespace. I mean, there's multiple ways of doing it, but it's probably the most practical way to go about it. By labeling the default namespace with data plane mode equals ambient, we're making the gateway part of the mesh. It'll get its own workload identity, and so communication between the gateway and HTTP bin will use mutual TLS just like any other pair of workloads that are part of the mesh. And so if we do that, we can rerun the ztunnel config workload command, and notice that now HBone is the protocol for both the gateway and HTTP bin. And if we rerun our curl request, we should see in the top panel, as soon as the logs get flushed, here we go, both an inbound and outbound, an inbound request and outbound response from the gateway to HTTP bin and back. And in both cases, we see the source and destination identities are SPIFFE URL, and they are present in the logs, which means we are now using mutual TLS. Now there's one sort of refinement of the configuration which is worth pointing out, which is that by default, when we make a workload, including a gateway, a part of the mesh, that basically means that Istio will intercept and ztunnel will be sort of in the path of those requests, both in the inbound and outbound directions. And for a gateway, what we're really concerned about is that upstream connection, the outbound direction. When the gateway calls HTTP pin, we want that to use TLS, but we don't necessarily want zTunnel to be in the path of the ingress on the inbound side at the gateway. And so we can actually exclude what we call inbound capture. This is a way with Istio to tell it that we do not want it to intercept those inbound requests. So you can sort of tell from a specific log line here about the source address. I think it's the line right here that indicates the source and destination, the destination being my gateway, was intercepted by zTunnel, and we do not want that. And so we can do this by, in this case, I show you how to do this through a kubectl patch command. We can patch the gateway deployment with a specific annotation, ambient istio.io bypass inbound capture set to true. And maybe I should target the bottom panel. And the moment we do that, we can actually look at the updated pod and notice that that annotation has been applied. And now that it's been applied, if I send another request, we'll see that the zTunnel logs will not output a line for that sort of inbound communication to the gateway. And that's essentially what we want to achieve. Now, to make this change permanent, we can actually configure a gateway class with a specific gateway parameters resource in kgateway to add that extra annotation by default, so we don't have to sort of patch our deployment after provisioning a gateway. All right, so that sort of summarizes the exercise, and hopefully it all makes sense. Let's look at essentially what our sort of main lessons learned from this activity have been. We note that Istio provides a way for third-party gateways to continue being your Ingress gateway. You don't have to switch to Istio at Ingress if you don't want to. In this case, we want to use kgateway as our Ingress gateway and control plane. And that we can enable mutual TLS for that upstream connection we were looking at by simply extending the scope of the mesh to include the gateway, by labeling the gateway's namespace. In that case is what we did. And finally, we also looked at this sort of configuration tweak whereby we configured Istio in such a way to tell it to bypass inbound capture for the gateway itself. That is, we were really only interested in the outbound communication from the gateway to any target workloads. Okay, so that concludes our lesson, and we'll see you in another one. Thank you.